Okay, in this video, we are going to look at comparisons, like how to compare one stuff with another. So that's the thing. Let's say you want to write a program to find greatest of three numbers or something, or greatest of numbers, lot of numbers. You might be using this comparison operator. Not like you might be, you will be using this comparison operator. So let's look at the basics. So I just start with real basics. So that's how it is. So yeah, let me just put a notebook and rename it as comparisons. So comparisons, okay. So like let's start with the basics. So is one greater than two? So I don't think so. So yeah, it's false, right? So one is not greater than two, right? Okay, and is two greater than one? Okay, fine. Two greater than one. Yeah, it is true. So yeah, don't leave a lot of spaces. Just leave one space between all these operators, right? And then yeah, one greater than one. No, one is equal to one. It's not greater than one. So now we have the question: what is equality? Okay, so okay. Now, if one is greater than or equal to one, look at the symbol. So, actually, how to remember this is like, okay, uh, look at the place where this is wider. So that should be greater than the place, the number where this is narrow. Okay, so if I put like, okay, this like this means this is true because the wider end is higher and the narrow end is lower. Okay, so this should be true. But if I put something like this is false because the wider end is lower and the narrower end is higher. So that's how it is. Actually, the wider end should be higher. But there is also a thing like you can do with greater than or equal to or less than or equal to sign. So this is actually called less than sign in mathematics. This is called greater than sign in mathematics. And we can do something like this. One greater than or equal to one, right? Okay. This greater than and equal to should stick together. It should not be like this, right? So yeah, it should stick together. Both have been read as one single operator. So that's how it is. So one is equal to one. Yeah. So that is true, right? So yeah, this is less than operator. We have seen yeah, five is less than three. Five is not less than three, so that should be false, right? And definitely three is less than five. That should be true. This is true, right? So that's how it is. And three is less than five. And it's not equal to 5, but anyway, like it just does any, if one condition satisfies, this will become true. So 3 is less than 5, so it's true. Okay, if you put like 3 less than or equal to 3, okay, yeah, this less than thing is false but equal to is true, so it kind of true. Okay, so that's how it is. So it just takes the true t uh, thing. Okay, so that's how it is. Yeah, this kind of stuff gives an error. So it is always less than or equal to, or what to say, greater than or equal to. It is never what to say like this one. Equal to or less than, no, it doesn't exist. Okay, or equal to or greater than doesn't exist. Okay, so okay, I don't know what this means. Okay, this one is okay. Okay, let me check it out. I think are we building some kind of dictionary over here? Like, okay, yeah, this is just for my curiosity. Okay, so pair. I don't know what pair means. Okay, right. Okay, fine. But yeah, this is definitely not a comparison operator. Okay, so this is a comparison operator, greater than or equal to. Okay. This should be false. Of course, 3 is not greater than 5 or 3 is not equal to 5. Okay, so that's how it is, right? So yeah, 3 is equal to 3. So yeah, this will be true. Yeah. Even though 3 is not less than 3, it is equal to 3, right? So this will be true. Okay. Yeah, and this is the equality operator. Look, this is not an equality operator. If you put like this, I don't know what happens. Yeah, it's a syntax error. This is an equality operator. Okay. One might ask, okay, then what is this single equal to? It is like, okay, A is equal to 5. Okay, you can do something like this. B is equal to 8. B greater than A. Yeah, something like that. Okay. Now, okay, yeah. We there is a double equal to is for comparison. Single equal to is for assignment. Okay. So you might ask, what is this triple equal to? Okay. So this gives, okay, okay, double equal to gives true if 3 is equal to 3.0. But if I put triple equal to, let's see what happens. Okay. This is false. And if I put something like, okay, like 3 double equal to 3, that's true. So what happens is there is type. Okay. So, okay, you can do this type of 3. Okay, every thing in Julia has a type. Okay, so type of 3, it is integer 64 bits. Okay, so I hope you people know about integers and all those stuff. If not, yeah, just go to integer integers. These are the things that separates computer people from non-computer people, like knowing this knowledge and all those stuff. Okay. So yeah, just go and read it. What are integers? Or yeah, actually mathematics people should know. I'll put this in description, right? So integers are number. Okay, in computers you can remember something. Integers are numbers that doesn't have a decimal point. Okay, this doesn't have a decimal point. Okay, so and there is a thing called floating point. Okay, floating point you can remember as, because now you are actually doing very high level programming. Okay, so no need to worry much about this unless and until very okay, it's not album, floating point numbers. These are actually I think okay, okay, yeah, you can just read about floating point, what are these and how they are being treated in computers and all those stuff. Apparently, you can't represent all numbers very accurately using floating point. But yeah, it has been used. All just remember that, okay, like it is a number with a decimal point is floating point. Okay, so that's the thing. So this triple equal to checks whether the types are also equal. Okay, so that's how it is. So their types are not equal even though their values are equal. So you need to know this if you're doing comparison. Okay. So I don't think you'll be using this one very often, but this thing, yes, you might be using. Right? So that's how it is. And yeah, so okay, like you are having like A is equal to 5, B is equal to 5, A triple equal to B, and I don't know what's going to happen. I don't think I've even the result. Okay. Okay, yeah, it says true. Thanks. Yeah, that's how it is. And okay, there is a thing called not a number in Julia. Okay, if it's not a number, or some cases where it's not a number and all those stuff. And it says, I don't know, like, okay, now we have a name in Julia, it means it's a number. Okay. Yeah, fine. Right. So, two not a numbers. Okay. If something is not a number, another thing is also not a number, how can you compare, right? So, you can't compare like not a number. Okay. Like, let's say, like comparing what to say, like, it's not at all a number. How can you compare? Comparison is all about numbers and measurements and all those stuff. Okay. So, it becomes false, but if you take this one, it becomes true. Okay, like that's because how it Julia does is, okay. Okay, let me just tell you something. Okay, so okay, like okay, so let me just explain it. I just need to do some diagrams. Okay, so imagine, okay, how this triple equal to works. Okay, so everything is a value in a computer. Okay, so like what happens is like every value has some address location. So Look, this is the computer. Imagine this is the computer memory. One is here, another piece of memory is there. You can just imagine memories as boxes. Okay, right? Now you can imagine variable names as I'll put as squares. Okay, variable names as squares. Okay, right? So, okay, right. Okay, right. So each and every memory location has an address. So let me just put it as something like some addresses. One, two. Just imagine like a house number. Okay, one. Okay, so these are all address. Okay, so one. Okay. Two. Okay. Three. Okay, so let me just put these as address and all those stuff. Okay. Let's say like you are putting a is equal to 5 and b is equal to 5. Okay, so this is a variable, so let me name it as, let me just put it in green. Okay, so this is variable. Okay, so this is a and this is b, right? Okay, and this is memory in computer location. Okay, so you are just putting 5 over here, right? You might think like, okay, in reality there is a bucket, okay, or A is a box and five is inside it, but actually not. Like what happens is like, okay, A is here, okay, and uh, it just imagine like A is getting pointed to this location, so it's been pointed to location, okay, so and this is being pointed to this location, okay, so B is also pointing to the same location. So what triple equal to does is it just checks whether these both are pointing to same location. Then it says yes. Okay. Let's say like, okay, we just put another thing called 5.0. 5.0 is not 5. Okay. In computers. So what happens is B gets pointed to this one. Okay. What double equal to does is it takes these two. Okay. It takes these two and checks whether the values in them are same. It reads the, it goes to location 1, takes the value, it goes to location 2, takes the value because B is being pointed to location 2, and it checks whether the values are same. Okay, and in this case, yes, that's for double equal to. But triple equal to just simply checks whether it's in the same location, but no, it's not in the same location, so it says these are different. So even if the types are different, these are different. And computers, like if you have a value that has the same type, and if you say a is equal to 5 and b is equal to 5, computer just assigns b over here. Like why should computer waste another location putting 5 over here or somewhere else, and then what to say, assigning b to it? That's just waste of resources, right? So this is how computer optimizes space and all those stuff. Okay, now let's come to our case, not a number. So let's say like this is in location, let's say I'll just rename this location as something like, there is a special, imagine like there's a location called 42 in computer, and over here is nan. Okay, so nan. So let me just check the spelling. uh what is NAN? Okay, NAN. Okay, right. Okay. So this is a very, very special location and all those stuff. So if you ask NAN is double equal to NAN, what happens is like the computer goes to location 42 because it knows NAN is stored over there. It takes that thing, and I'm talking about double equal to. And once again, it goes to location 42, takes this NAN. Okay, and how can I compare numbers? It just thinks, okay, I can't compare numbers, so it's false. So double equal to gives false. For triple equal to, it just checks the location. Okay, both these things are in same location, so it should be true. So it just gives true. So that's how this works. Okay, so I hope you understood it. So yeah, that's how it is. So okay, and that's why you just get true. Okay, and there's another thing called not equal to. Okay, so like you can put like this, right? Okay, so 4 not equal to 5. Of course, it's not equal to 5. And 4 not equal to 4 is false. Okay, so, and we can also write something like this one, right? Okay, 4 not equal to 5. Maybe we can even write like this one. Okay, 4 double equal to 5. Okay, that's false. But we can also put something like this one, right? This is a not symbol, right? Okay, so that's how it is. But the thing is, this is more elegant, right? And that's how it is. Maybe it might even require less operation inside the computer. So that's what, like, so for not equal to prefer this one rather than this one, because this, it needs to go to the location, take the value, compare, then it should apply a not for that. So this all requires moving data here and there and all those stuff. So that's how it is. So yeah. So yeah, these are the comparison stuff, and possibly this thing can apply to even a lot of languages, because a lot of languages do have the very same stuff for comparison and all those stuff. Okay, so it applies to the same thing. Yeah, I will put what to say, these what to say URLs uh, in the video description. So I hope, yeah, you are okay with my explanation of comparison. Anyway, let's meet in next video.